Hi everyone, welcome to the Petroleum Engineering Economics 3101, the review class today. And as I said, the email, our final exam will consist on three chapters. The chapter 5, the initial project screening method or payback period. Chapter 8, depreciation and corporate tax, and chapter 15, the project risk and uncertainty. Okay, so there are some other chapters, but I am actually not taking all these others. We'll not go in depth of the sensitivity analysis, but we'll actually cover these three chapters. But the most important part is the chapter 5 because it's a little bit lengthy and big, and it's actually the base of other two, like the depreciation and the project uncertainty. So uncertainty analysis. So I'll actually go through all the lectures today, and then we'll actually see what would be important, what could be better for our, to cover for our final exam. Now the most important part is we're actually following the Contemporary Engineering Economics, the third Canadian edition. Okay, so remember, it's the third Canadian edition. So if you have any other editions or some resources uploaded in the Moodle by me, are probably like the other editions, like international editions. So remember, we'll actually follow through these slides. Okay, so through these slides, all the problems and everything will actually cover. But in our final exam, the questions would be rather unseen, and also it would be since it's the take-home exam and it's not a group assignment type. Okay, so it's the individual take home. The whole exam time, you will get at least 2 days to solve the problems. Okay, and you will be uploading at the Moodle. Okay, so it would be similar like how you actually submit the assignments, but it would be totally individual. Okay, and the submission mode would be only through the Moodle. Again, if you email me the final exam question answer sheets, that not going to count. Okay, and again, I want to remind you, if anyone failed to attempt the final exam, so he or she will be marked as incomplete, and incomplete means that you have to as the register after the semester is over, then you have to reappear the final exam again to get the grades. Okay, so keep in mind that. So I would highly urge the students to sit for the exam. But again, like if you do not have at all the internet availability or access to the internet from home, so that would be incomplete. Okay, so let's start with the chapter 5, the initial project screening method or the payback period. We went through these slides. Okay, so we already went through here, like these short little story that there's a car parking method. So what types, or what are the modes, options actually we have, and from all these options, which options should we actually choose? Okay, so for instance, we have we could have an option for in-car meters, or multiple handheld alerts, or pay by the cell phone smart meters, or infer the license plate scanner. So there are multiple types of different modes. Okay, so what would be the options we'll have? So this in this case, what we actually things like, I mean, okay, so one point of view is for the um, company. Okay, like, I mean, you are the company, you want to invest in a project, so it's your point of view, you want to maximize the profit or you want to save the money. Okay, and another is the supplier's point of view, in this case the municipality and the manufacturer. Okay, so manufacturer is a supplier, so supplier, what they would be want, like, I mean, they want to sell the product. Okay, so there would be like, okay, so if you have enough demand for the product, so they want to create the demand, okay, to supply. That's the number one. And also the potential risk if the demand actually go less, okay, or high, or we don't know. So for instance, giving an example, right now the crude oil price, you can see in the whole world, is very low. Why is that? Because some countries, they actually overproduced it, and when you actually do the overproduction, then what's happened? Then the price actually get fall. Okay, and the supply is way above than the demand, so that's exactly why the price fall. Now this is good for the refineries and the oil distributors, because they can like buy the crude oil in cheaper price, but it is bad for the oil producing countries like Canada. Okay, so this is how it works. Now this is a very crucial time, and I'm sure, like, I mean, having a knowledge on engineering economics will actually give you a better understanding and better idea, like how this oil price and everything actually is working now, and how we can actually mitigate the problem and came out from this problem. So let's start. I will actually quickly go through everything, because since it's a review class, so we will not take much time in one instance, and there are lots of content actually. So we'll just start it. So this is chapter 5 again, from the Contemporary Engineering Economics, third edition, lecture 1. So the first thing we have learned, like the bank loan versus investment project. So what's bank do? Bank actually give the loan. Okay, so bank give the loan to the customers. Okay, and what company do? Company actually invest in a project. Okay, so this is the loan cash flow, this is the project cash flow. Right, fine. So we already went through this example 5.1. Okay, this is a very important example, because based on this example we'll actually see all other problems and the solutions also. Okay, so here it says chemical industry, they're thinking of installing automatic process control system, and that actually cost money, but that is an initial investment. But using, I mean, if we invest that, then it actually increase the efficiency and decrease the lag time, or like that you reduce the operating hours and reduce the number of operators. So, and it also increase the product quality. Okay, so we have to determine overall it's this system is good for us or not. That means like if it's viable or not. Okay, so this is how we actually solve the problem. So we already solved in the class. So if you have any question on this, let me know again, but I'm not going through in detail because it's already been done in the class. Okay, now here is the project cash flow, and from there we have determined like, okay, so it's a 8 years project, and from there we actually cannot get any idea, like, I mean, if the project is viable or not, but we will learn it the next math. Okay, so this is an independent and mutual exclusive investment project. So we went through these things, payback period, and what is the payback period? Initial cost divided by annual benefit. That means initial cost it was $650,000 of that instrument, and annual if it was 162, so the payback period became four years. Okay, now that machine also had the salvage value. Okay, so we have added the tax and we calculated the payback period is 3.2 years if we have the salvage value. Okay, so we already got the problem. Now let's solve another problem. Pipe Tech Corporation, they bought a new machine and that replaced the older one, which got a salvage value of $20,000. Okay, so the projected annual after-tax saving for improvement, which will exceed the investment cost. And for instance, the rate of return is 15%. So we'll check if the project makes sense or not. How can we do that? We'll see the period. Okay, so we'll draw the cumulative cash flow, and from there we've seen like, okay, it's near like a little bit more than 4 years. Okay, the discounted payback period we have drew, and from there we can think like, okay, so the total project time was 6, the payback period is like nearly a little bit more than 4. That means the project seems viable. So this is about the lecture 1. Okay, so we'll actually go through the lecture 2 now. So lecture 2, we actually make a baseline, and that baseline is introduction of NPW or NPV. So from NPV, we actually determine that if the project makes sense or not. Okay, so if the accept or rejection decision making criteria. Okay, so that's will actually determine. Now we already know what is MARR. Okay, so MARR is the minimum acceptable rate of return, and how we actually determine the present worth. If we have net cash flow at the end of the period, I is the MARR and N is the service life. So this is the formula, and here if the present worth is greater than 0, that means it is accepted for the investment. If it remains 0, that means it is indifferent. That means there is no gain or loss. But if it's less than 0, that means we'll have a loss, so we'll not invest in that project. So again, the same example of 5.1, now it says like if the MARR is 15%, now is the project acceptable or not. Now the last lecture we have seen that we have actually determined the payback period. Okay, but that period didn't had any MARR, but here we have the MARR. Okay, and this is 15%. So now let's see. Here we have the present mode, then we have calculated the present mode, and that is a positive value 79,000. Okay, that means the project is acceptable. Let's go to another example. We already have done this example, but it says the MARR is 15%. We have the net cash flow again, if the project is viable or not. So what we can do, we have the investment in here, we have the inflows, we can convert all these in here. Okay, at our present worth, then we make the difference, and we have seen yes, the value is greater than 0, so the project is acceptable. Now what would be the profit of the project? That will actually see, like, I mean, what would be the critical MARR? Okay, what would be the critical MARR? That we can actually define like this. Here at 17.45%, the present worth become 0. Okay, that means at this point we'll have neither profit or not loss. That means the cash inflow and the cash outflow would be same at the present time, okay, or t equal to 0. That means this is our critical MARR. So if the MARR is above to that, the project is not viable. But if it's below to that, that means the project would be viable. Okay, so this is how we actually determined the viability of the project through NPV. Now in that example, the previous example, we have $3,553. What does really mean? What is that? And how can we actually explain the meaning of MARR and the NPV through the investment pool concept and the borrowed fund concept? So the investment pool is something, it's like a firm's treasury. So the firm can actually withdraw the money from the pool and for investing in one project, okay? But if the firm actually don't want to invest money in that project, the firm can just put that money in the pool and it will actually generate the continue earning the MARR, or we can say like the to the interest rate. Okay, so for instance we have two options. Number one, we'll actually get the money from the investment pool and we'll invest in the project, and whatever return we get from the project will directly return it to the investment pool and earn 15% interest rate yearly at the end of the period. Okay, and the other option is like we'll leave the money in the pool and will not invest in that project. Okay, so let's see which one is more profitable. Now in this picture you can see it's pretty straightforward. Like for 3 years time period, if we just put the money in the investment pool and earn 15% MARR, so $75,000, after 3 years later it becomes $114,000. Okay, a little bit over than that money. But this $75,000, if we invest to buy this equipment, okay, what is that equipment here? This pipeline inspection tool, okay, and then this one actually earn or like save the expenses, okay, and the savings directly goes to the investment pool. Okay, and in the end we have calculated in here, you see, we have calculated in here that money, $3,553. Okay, so that money is this one, and the future worth of this 3,553 would be what? $5,404. That means this is the net benefit of investing the project. That means the project is viable, and this is the main concept of the investment pool. Okay, so we also went through this, so I'm not explaining much in here. So these problems are very, very important. The basis of selecting MARR is the cost of capital and the risk premium. So mark it well, because we already have seen how this thing work. Okay, now just like present worth analysis, we can actually do the baseline with the future worth analysis, but as I said in the class, mostly we actually calculate everything with the NPV, not net future worth. But in some cases we actually doesn't do the net future worth analysis, but that would be beyond our beyond the scope of our syllabus. So mostly we'll do the analysis through the NPV. Okay, so this is one of another example how we can actually do the net future worth criterion analysis. Okay, so again, just like the same principle at present value, if the future worth is greater than 0, we accept the investment. If it remains indifferent, that means future root is equals to 0. And if the future root is less than 0, that means the we'll reject the investment because we don't want to get a negative balance. Okay, so here is the case for the example 5.6. So this is about the lecture 2, and the lecture 2 is done. We have started the lecture 3 at our class, but at that point the class has been postponed. So it is about annual equivalent worth criterion. So just like the present worth, future worth, we have the same principle or the decision making rule for the annual equivalent worth also. And what is that? If the annual equivalent worth is greater than 0, we will accept the investment. If it's equals to 0, then it will remain indifferent, and if it's less than 0, then we'll reject the investment. Okay, so there is another example, very similar one with the previous, and we have the annual equivalent worth for a single project evaluation. Go through this problem, and it's if you can solve those other two, you can solve this one. It's a very easy and straightforward example, and everything is already given. So go through this problem and solve this. Okay, what would be the annual fuel saving? So you'll find this one in here. So I'm actually giving you an example in here, like the geometric gradient. The midterm we didn't cover this, but this is just the formula for the geometric gradient. Okay, now how the geometric gradient actually works. So this is the straight line, and this is how the geometric gradient works. Now in your question, if you actually go through this question, you will find like if the fuel cost increase like 4% each year. Okay, so that's how you will actually adjust it. So this geometric gradient actually give you that answer. Okay, so if the fuel increase 4% each year, so what you will do in this case, in case of small g, you will just replace it with the 4% or 0.04, and you can solve this problem based on this criterion. Okay, annual equivalent worth for repeating cash flow cycle. Again, you can see it's a linear increment, and again I'm flashbacking the linear gradient, which is capital G. Okay, so P and the capital G. So if everything is given, you can just put it in the formula, and you can actually calculate the worth and replace the second replacement, and you can calculate the in PW, and from there you can calculate annual equivalent worth. Okay, so this is the formula for that. Now just a second. Now we'll actually learn on the capital cost recovery and capital cost versus operating cost. Which one is the capital cost, which one is the operating cost? I'm sure I already have discussed about the capital cost and the operating cost. That means capital cost we can also say like this is a kind of like fixed cost. Okay, so for instance, you want to buy a car. Okay, so if you purchase a car, so that cost is the capital cost, but for the gas, for the regular schedule maintenance and everything, so those would be your operating cost. Okay, so there are two different costs involved. Now when you actually think about a project, okay, so just imagine this one. Your car cost like $20,000, and you do you want to pay $20,000 upfront? Most of us don't. What do? We actually go to a bank, and then we actually ask the company like, okay, I want to get the car, but I want to get it through the installments. Okay, so they actually analyze your profile and everything, and then they determine like, okay, so each year you have to pay this amount of money. In most cases they actually calculate through month. Okay, so like, I mean, each month you have to give this amount of money, so we call it like monthly installment. So just think about like this is an annual, in case of industries it's just an annual equivalence. Okay, now your this is your capital cost. So you actually divided your capital cost like this $20,000, okay, over a time period. Usually it's like 5 to 7 years, and each year you have divided these equal parts. Okay, and each year you have the operating cost also. Okay, so if you add those two, capital cost in each year and operating cost each year, so you got every year annually how it works. Okay, and if you actually substitute, like subtract with your earning from that car, okay, or the cost saving from that car, that would be your gain, right? So this is the thing. So let's do some problems. So this is the capital recovery cost formula. So how we actually do that? So for instance, your car life is like 10 years. Okay, so you bought the car, and after 10 years later you've got the car for like $20,000. After 10 years later you can sell it like $5,000. So the total car value would be $15,000. Okay, so this is how you actually calculate the capital cost. Okay, this is the formula for it. Now let's do some math. So consider a machine that cost $20,000. Okay, it got 5 years of useful life, and at the end you can sell it $4,000 after the tax adjustment. Now the annual O&M, that means operation and maintenance cost, are about $500. If the firm could earn, and after tax revenue, $5,000 per year with this machine, would it be purchased at an interest rate of 10%? So now we have two different costs. One is capital, another is operating. So the capital cost is $20,000, but we have a salvage value, which is a gain, $4,000. Okay, and operating cost is $500 each year. So how can we balance it? So we can actually get the equivalent worth. Okay, that's how we can make the strategy. So the capital recovery would be 4,620. How? $20,000 minus $4,000, and we make this equivalent. Okay, so this is the formula. Remember which formula we have used. Okay, and from here we actually got the CRR, capital recovery, and we also know the operation and maintenance cost each year is $500. So if we add these two, just like here, capital cost and operating cost, we add these two, then we'll get the total AEC. Okay, and which is $5,120 annual equivalent cost. Now what is the annual equivalence? Each year it is says annual revenue is, if the annual revenue is 5,000 or large enough, right? So if our baseline is 5,000, we just substitute it and we have found like this is negative value. That means the project is not viable. Okay, so how can we actually justify these things? So this is the cash flow diagram. We can actually see how the cash flow diagram works. Okay, so this is the problem actually working. Okay, now unit profit or cost calculation. So the number of units, how can we calculate that? From the cash flow analysis, and also we'll calculate the NPW. and from there we'll calculate the interest rate to determine the annual equivalent load. Okay, so for instance, Enbridge, they want to buy a new pipeline inspection tool, and the initial investment would be $75,000, and the project timeline is 3 years period. Okay, and this is the MARR 15%. We already have seen this problem at the 5.5. Okay, now what we will actually do, considering that problem, okay, recalling that problem, the 3-year investment was expected to generate an NPW of $3,553, and suppose the machine will be operated for 2,000 years per year. Okay, compute the equivalent saving per machine hour. Okay, at I equal to 15%. So this is the way how actually we do that. The operating hour is each year 2,000 hours. Okay, so we calculate the PW, we calculate the AE, and we divide it with machine hour. Then we can get like the savings per machine hour. Okay, that's how we actually calculate it. Again, there is another problem. Go through there and solve it. Okay, it is like using the same principle. Price using an asset. Go through this problem and solve these also using the same principle. Now we'll actually go to the lecture 4, and lecture 4 would be like the same like the rate of return. Okay, interest earned and loan balance rate of return. What is ROR? It's the cash inflow minus cash outflow, that break-even interest rate. Okay, where it becomes 0, that is the rate of return, or ROR. Okay, so this is also called the break-even interest rate. You remember the break-even interest rate? Last lecture we have seen. Let me show you. Not this one. Here, lecture 2. Here. Okay, the very similar concept we'll have. Now, here. Here. So, this is the mathematical relationship. ROR, initial rate of return. The company invests this amount of money in a computer, and the result, the equivalent annual labor saving, is this amount of money over 3 years. The company said the rate of return is 10%. That means the cash inflow and cash outflow becomes 0 here on the investment of 10,000. Okay, this is how we can see the balance. The simple versus non-simple investments. I just need to go through that, but I mean, you don't need to do too much. So, but if you want to find the I, there are 3 different solutions. Okay, one is direct solution method, trial and error, and computer solution method. Let's see how actually we can do that. So it is just like the same thing, how we can actually calculate the I. So it's a quadratic did the equation, and now we can actually calculate the I with this one. Okay, and also we can do the iteration, and through the iterative method we can, that's also we called trial and error method. Okay, from the iteration, like in this problem, you remember this tier 2, here we actually did the iterative method to like 14, 16, 17, 17.5, it became 0. Okay, so that is the iterative method, how we actually do the trial and error and find the I. And this is the graphical approach using the computer. So it's an important concept, okay? Do this problem, do the examples, and if you have questions, just let me know. Internal rate of return is the interest rate that earned on the unrecovered project balance of the investment, and when the project terminates, the unrecovered project balance would be 0. Okay, is the IRR. Now, what is the decision making criterion? Should we accept or reject the project? If IRR is greater than MARR, then we'll accept the project. If it's same, then it will remain indifferent. And if the IRR is less than MARR, then we'll reject the project. Okay, so here is an example. Example 5.2. Go through this problem. It's in your lecture note. It's updated. Go through this problem and solve it. Okay, we will have this solution in here too. Decision making rule for non-simple investment. This is the flow diagram. So the cash flow sign out rule, simple investment, non-simple investment, and how we can actually calculate the IRR through the iterative method, okay, or pass or failed, and that's the criteria. Okay, the IRR should be greater than MARR. You don't need to go to this 0.21. That would be okay. So this is all about the chapter 5. Now let's go to the chapter 8. So the chapter 8 is the depreciation, and there's a few concepts about the depreciation is given, and I already told you at the class what is the concept of depreciation. Depreciation is something your loss of value of an asset, okay, and how it actually works. Now we have measured like two different types, like economic depreciation and accounting depreciation. Economic depreciation is a straightforward, like the purchasing price minus the marketing value. Okay, for instance, you bought an iPhone and market value was $1,500, but right after you purchase the iPhone, if you want to sell it, it's not $1,500 anymore. Okay, so the price has been depreciated. Okay, physical depreciation. Physical depreciation is the reduction of an asset's capacity. For instance, you buy a car and you actually drive it for 1 year, but you remember the example of Mazda. Okay, so Mazda got the corrosion very easily. So what's happened, you got a Honda or Toyota, and another of your friend got a Mazda, but after 1 year later the Mazda looks more rusty. That means what? It got more physical depreciation than the depreciation of your car. Functional depreciation. Let's give you an example of functional depreciation. For instance, you and your friend both bought a car 5 years back, okay, in the same price, but you bought an automatic system. For instance, your car have the cruise control system, automatic gear shifting and changing systems, but your friend's car got a manual system. Okay, so after 5 years later, what do you think, which car would have more depreciated? Definitely the manual one, because nobody would going to buy that one, because that's an obsolete technology right now. Okay, so that's kind of like one example of a functional depreciation. Okay, you can also get an example like a push and pull cell phone right now. Okay, so nobody actually used that one. I mean, very few. Why? Because you cannot actually connect with high-speed internet to the push and pull. It's not a smart device. Okay, so that's why it got a functional depreciation. So these are different examples of the economic depreciation, and the accounting depreciation is based on the matching concept. And what is that? That is, a fraction of the cost of the asset is chargeable as an expense in the each of the accounting period. Okay, so that is the accounting depreciation. So give an example. For instance, you purchased a machine, okay, but that machine, the entire acquisition, the cost of the machine cannot be charged to any 1 year's production. Rather, what you do, the cost is shared, or we call it capitalized, over the year in which the machine is in service. Okay, so for instance, if the machine actually run for 5 years, okay, the cost we actually capitalized or spread it around. Okay, so this cost charge to the operation during a particular year, we call it depreciation. Okay, and that's we call the accounting depreciation. So from engineering economics point of view, our primary concern is with the accounting depreciation in here. Now you can see the classification and the type of the differences. The accounting depreciation got book depreciation and the tax depreciation, but in here right now in this course we'll just follow the book depreciation. I actually deduced the tax depreciation from the course because of our course length and time will get larger. Okay, so that's why we'll just the book depreciation. Now there are the depreciable properties, which are depreciable, which are not. For instance, land cannot be depreciated because the value of land do not wear out, okay, or become obsolete, number one. And the asset should have a definite useful life, okay, and it should be used in business. So these are the primary definition of the depreciable properties. Okay, information required to calculate the depreciation. Number one, the cost basis, depreciable life, salvage value, if it has any salvage value or not, and the method of its depreciation. Okay, so cost basis actually the total cost claim. We'll actually learn a little bit more later. For instance, you want to buy a machine, so it got transportation cost, labor cost, and different tax and other costs. So the cost basis would be the summation of everything. Okay, that's we call the cost basis. You can actually, now the cost basis, when I actually say there are something like negative, for instance, trade-in allowance. Okay, so that will be deduced from the cost basis. Okay, here you can see in this problem. Okay, each year we have unrecognized gains. And the useful life, we know what is the useful life. We already have the concept of is salvage value. We also know what is the salvage value. Okay, book depreciation and tax depreciation, the types of the depreciation and its definitions. So there are three different types, three different methods actually to calculate the book depreciation: straight line method, accelerated method, and unit of production method. Okay, so these are the formula. This is a straight line depreciation method. Go to this problem and solve it. Okay, just remember the 5 years in service life. That means equal to 5. In case of like the straight line, the multiplier, okay, so the multiplier would be 1 by 5. Okay, 1 by 5 straight line. If you use this formula, okay, multiplier would be 1 by 5. Now in case of declining balance, you will see the multiplier is d equal to 1 by n. The multiplier equals to 1, and this is the formula for it. Okay, You can just plug in these values in this formula and you can actually calculate with the declining balance method here. SOYD, or sum of years digits, the same. We have the formula using all these values and you can actually calculate the SYOD. How you can calculate it? 1 plus 2 plus 3, so total 5, sum of all years, and then we can determine unit of production method. At first we will actually calculate the depreciation charge for a period related with the number of service unit consumed in that period, okay, and then we can actually calculate the unit of production depreciation period, okay. All right, so this is about the depreciation. Now the final topic in our syllabus is project risk and uncertainty. So project risk and uncertainty is there are lots of different examples we can give. One of the example would be the oil forecast. Right now we can see like the oil forecast is really, I mean the oil price is really low, and in the future how it could be, how we can actually predict like if the oil price is going up or down, or since the oil price is down right now, what are the consequences for the different industries, how these how we can actually do the uncertainty analysis, and what are the factors that actually fluctuate this uncertainty, okay. So these are the things we can learn. Now here what we will not go through are we'll actually go through the sensitivity, but the risk modeling will just go through it, but will not actually develop any risk model. If we had time, more time, then we'll actually develop risk models, but here we'll just go through it, okay, but we'll not physically develop any model for the risk. So these are like the project risk, cash flow, we all know about these things. So what is the sensitivity? Sensitivity analysis means identifying those project variables and vary those, and each particular parameter has effect on the project, okay. So from the sensitivity analysis you can find out like, I mean, which parameter have the greatest effect on the acceptability of the project. Break-even analysis, it means identifying a value of a particular project variables that cause the project to exactly break even. We have seen what is the break-even point, right? We already know. Scenario analysis, a meaning of comparing the base case, okay. For instance, NPV would be one of the measurement of the base case, okay, or AE is another. So there's a problem with the sensitivity analysis. Read that and solve it. It's a very simple problem. I'll actually give you a solution of a problem, the next one, okay. So this 15.1, please go through this and solve the problem, okay. I'll actually show you this one, how to do this, how to solve this problem. Now what the question actually says in here, in this problem, it says the local Canada Post Service office is considering purchasing a 2000 kg capacity of forklift truck, which will be used primarily for processing incoming as well as outgoing postal package. The forklift these trucks traditionally fueled through LPG, but we have some other options: LPG, gasoline, diesel, and electric. Now each year we have somewhere between 200 and 260 shifts, and Canada Post used 10% as its interest rate for any project evaluation of this kind of nature, okay. So you have to develop a sensitivity graph that shows how the choice alternatives change as a function of the number of shift per year. Okay, so this is like the sensitivity graph we'll actually draw, and from there we'll determine. So this is the chart. Okay, here it's a chart. We have 4 different options: electric, LPG, gasoline, diesel fuel. Now here the initial cost, salvage value, and other fixed costs are given for all. We have the life expectancy, that means project time is also given, project life is given in here. We also have the salvage value, that means we can calculate the CR, or capital recovery. Okay, now we have some variable cost too. For instance, the fuel consumption per shift and fuel cost per unit, fuel cost per shift. So all of these are variable cost. Okay, so what do we know? The solution. Remember how we determine the capital cost from chapter 5. Okay, so from chapter 5 we know this is the formula for the capital recovery. Okay, so capital recovery or capital cost. So we determine capital cost for H items: electrical, LPG, gasoline, and diesel. So when we actually get the capital cost, what is the next one? We want annual operating cost. Remember, these are all like annual. Okay, capital recovery means annual capital cost and annual operating cost. So let's assume our annual, because it says the operating the shifts are actually in between 200 and 260. Okay, so just assume its number is M per year. Okay, so if it is M, then what? Then for the electric power, LPG, and gasoline, we have these equations. Okay, for the operating. How? Because this is the fixed cost, $1,000. Remember here, annual maintenance cost, fixed maintenance cost. Okay, plus this is the fuel cost plus the variable cost times number of shift. Okay, so what we got? 1000 plus 11.38 M for electric power. For LPG, 2000 plus 14 plus 22.45, 36.45 M. So for diesel we have another equation. So we have 4 set of equations. Now these 4 set of equations, we have the AE 10%, and we add it with the what is AE? AE is the CR plus AOC. That means this plus this. Okay, CR plus AOE. That means here 13.3K plus 1K. That means we got 14.3K plus 11.38 M. So we have a set of 4 equations. Now if we draw this equation, this is one variable, this is another variable, so we can draw a straight line. Okay, so this is the number of shift and this is the annual equivalent load. Okay, now you remember if AE is greater than 0, then our project is viable, right? Now here the annual equivalent cost, now we actually want to reduce the cost in here. So what is going to be happen? So if A is lower, then our selection will be better. So if the number of shift is between 100 and 80, like I mean 200 or less than 210, then the diesel is more preferable choice. But if the number of shift is more than 220, then in that case electric is more preferable by plotting these mutually exclusive alternatives. Okay, so this is actually the sensitivity analysis. Okay, So we can actually come to the conclusion how we can actually make the decision. Clear, everyone? Just like this, we have some other problems. Okay, the solutions are given like the please solve the 15.1. Okay, now we'll also do the break-even analysis, and we already have discussed what is the break-even analysis. Break-even analysis, at which point the these cash inflow and the cash outflow becomes equal. Okay, so go to this 15.3, solve the 15.1 at first and go through the 15.3, and please determine the break-even points in here using this equation. Okay, so and determine the number of break-even number of units. This is the break-even point. Okay, scenario analysis. Scenario analysis is as we said already, is the technique that considers the sensitivity of the NPW for both changes of the key variables to range of likely values of those variables. Okay, so it will give the cases like the best case scenario and the worst case scenario. Okay, so 15.4 gives the similar types of best case and the worst case scenario, and from there you can actually get the most likely case scenario also. Okay, so this would be our lecture 1, and the lecture 2 is the probabilities and the probability distribution curves. Okay, the risk analysis will just learn the very high level in here. Okay, so what are the distribution analysis, what is the cumulative distribution, okay, what is the cumulative probability distribution, and how it actually we can draw. So these are the things. You don't need to get very deep because we will not cover these okay, so this is the variation, what is the mean and variance. So these are like, I mean, the old statistical concept actually. So this is the covariance and coefficient relationship. Okay, so this would be all of our lectures for the project risk and uncertainty. Okay, and our final syllabus. So in case of your final exam, what's going to happen, you will have 8 to 10 questions, and each questions you have to give the answer. Okay, and then you have to submit it me through the Moodle. Okay, so it would be all mathematical types of problem. There will be no theoretical types. So from chapter 5, 8, 15, so you can use the concept of those, and also there could be some unseen type, but it would be not like you cannot solve it at all. Okay, it would be not like that. It would be based on what we have learned so far. So good luck, and if you have any question, just let me know. Okay, you have my email address and everything, so let me know about the theoretical. So this is about the theoretical part. For the lab, I will also upload the problems for the lab, and it will be also individual problems. So the final exam for the labs would be also available in the Moodle at the same time when I will actually upload the final question for the 3101 theory. Okay, and most likely today is 3rd, so most likely by Monday or Tuesday I will upload the questions, and I will actually let you know beforehand. Okay, so probably on not Monday, probably Tuesday or Wednesday, I'll actually upload the questions. Alright, good luck, and let me know if you have any questions. Best wishes and stay safe at home. Bye.